Good morning. Today some information, geological information concerning sources of sediments deposited in the Nile River. Starting from south, from Sudan, we have magmatic and sedimentary rocks. Later I will say something about left bank of the Nile up to Delta, and next about right bank, East Desert, and sediments and various rocks. At the end will be information concerning the position of sediments at the delta of Nile. So we start from Sudan, from Nile Valley part of Nile Valley in Sudan, and we have the magmatic rocks, type of alkaline basalts with typical composition of basalts. There are olivines, pyroxenes, plagioclases, alkaline plagioclases, and plenty of other minerals, and they constitute the most frequent rock at the West Desert in Sudan and East Desert in Sudan, and after weathering, weathered material is deposited to the Nile. Together with these magmatic rocks, a big area of Sudan is built of Cretaceous sandstones. There is an example of this sandstone with hieroglyphs with descriptions, and after weathering, this rock is transformed mostly to the grains of quartz, which is transported next to the Nile. And the West Desert, part of Egyptian part of West Desert, there is the Nile near Edfu. It's a big river, and I will tell some information about rocks present at West Desert according to my examination at the area of Deir Bahari and Armand, this area in part at Abydos too. Left bank along the Nile is composed of Theban limestone of Eocene age, containing flints and underlaid by Esna shells. Esna shells, there is complex of shells intercalated with layers of limestones too. And the main type of Theban limestones is seen under the microscopy, polarizing light microscopy, like this. The material transported to the Nile is represented by grains of limestones, fragments of flints built of chalcedony, as well as by flints, as well as shells represented by clay minerals, mostly illite. In the past, all left bank of Nile River built of Theban limestones, like these, limestones with flints, was covered with red soils called terra rossa. During years, these layers of terra rossa were thicker and thicker. Thickness of this layer growth, but when climate started to change, this terra rossa was removed by rains as well as by winds, and material was transported to the Nile River. So the surface of Theban limestones along all left bank of Nile was covered with fragments of flints, because soft and delicate material represented mostly by kaolinite in terra rossa was removed, was washed out by water and removed by winds, and at place were left flints. And these old flints we may observe on all area of presence of Theban limestones. Red soil terra rossa was preserved only at some places, but mostly was removed to the valley of the Nile by wind and by rains, and deposited along the Nile, very, very low in morphology. So there is morphology of Theban limestones covered with flints left after removing of terra rossa. They are dark flints, altered because of weathering, and all area of presence of limestones were covered with pebbles of various size, like there, and so was developed so-called stone desert. There is near Castel Saga, the top of Theban limestones covered with residual flints. Terra rossa primarily developed on Theban limestones was preserved only at very special places. One of these places are caves present at Theban limestone. Near of Armand there is great cave, and inside one can find traces of terra rossa, not explored cave, very interesting with traces of pottery and so on. Probably thickness of archaeological layers is quite big. This cave is located west from Nile, near of slightly to the north of Armand. And material redeposited, terra rossa redeposited from Theban limestones is localized, is deposited at the lower part of Nile Valley as sediments. This is example of terra rossa at secondary position near of the Nile, very low in morphology. This terra rossa was washed out from Theban limestones, from top of Theban limestones, and this is mixed with fragments of flints. This is flint, and rounded gravels of Theban limestones. It's interesting and important because this red soil, terra rossa, is the main source of the material for pottery production since last a few thousand years. And we have there kaolinite, quartz, and limestone. East Desert. The Nile near of Luxor, it look like this. It's quite big river still. And East Desert is very complex. Practically we have each type of rock distinguished by petrography, magmatic rocks, and sedimentary rocks and metamorphic rocks. So it's difficult to describe all these petrographic types of rocks, but it's very big source of many various minerals transported to the Nile. And there are magmatic rocks type of granite, so-called Aswan granite, and gneisses of various types, metamorphic rocks, siliceous rocks containing some interesting minerals. There are volcano rocks containing volcano ash, like this, for example. There are at last metamorphic rocks type of serpentinite and jadeite and so on. All these materials are transported to the Nile. Were transported, now is transported slightly by wind. And Nile Delta, near Benha, Nile is one of branch of delta look like this. It's much smaller river, and the reconstruction of the past of last, let's say, about 22,000 years is shown on this drawing, and the earliest stage of formation of delta. There is Cairo, there is Mediterranean Sea, this blue. The elevation of land of North Africa in comparison with Mediterranean Sea was lower about 80 or never even 100 meters. So the Nile water between Cairo and Mediterranean Sea was transported very fast, because this is the same difference of elevation like between Cairo and Upper Egypt, about 100 meters. So the distance is much smaller, and the Nile flow there very fast between Cairo and Mediterranean Sea at, let's say, central stage of Pleistocene. Later, after the dissolution of ice sheet, this level of sea was elevated slowly up. So, sorry. And the elevation of Mediterranean Sea made a situation that at the beginning of Holocene, the Mediterranean Sea was about 20 meters lower than now. And material was transported more slower, because the difference between elevation of Cairo and Mediterranean Sea was smaller than at Pleistocene, so river flow slowly and deposited very fine material. Together with transport of material by Nile, it was additionally volcanic ash transported from the volcanoes of Mediterranean Sea. This ash was deposited and mixed with the material transported by Nile. Now it's seen as presence of kaolinite from red soils, from covers of Theban limestones. This kaolinite was mixed with volcano ash, mostly volcano glass, and this volcano glass was transformed to clay minerals, mostly smectite, and presence of mixed clays, kaolinite, smectite, is confirmed by publications of other authors. So there are some layers of clays, of silts in delta, composed mostly of kaolinite. This means material was transported from south. And some parts, some layers are enriched with smectite. These layers were deposited as volcano ash transported from volcanoes and later transferred to smectite. Both minerals, kaolinite and smectite, are very good for production of pottery, but they need other temperatures of firing, because kaolinite is very good for firing and preparation of hard pottery, but smectite not too much. Its temperature of firing slightly higher than 800 degrees Celsius. Kaolinite start to be changed, and pottery is porous and look like slag. Is changed to high temperature, and smectite as material used for preparation of pottery is not very good. And next situation is at our situation is present time. See, it's the same as Cairo. Delta is much smaller and elevated above sea level 3 up to 5 meters. Probably in the past this elevation was much smaller, and sometimes water of Mediterranean Sea may flow into the delta, covering big area, because we know that north edge of Egypt, north edge of Africa is still going up. So because of this now, probably because of this now, delta is elevated not too much, but 3-5 meters above level of the sea. And this is the story of formation of geysers, which were deposited much earlier, made of sand, by wind probably, and later were covered at some places by deposits of the Nile, and in part deposits by sea. And these elevated tops of Gezira were very good places for occupation, for human occupation, and one of these occupations is Tel el-Faha site, discovered by Italians and explored now by Polish Egyptian mission. So this is not sharp photos because it's very enlarged. There is example of Nile silts from Delta, clay minerals, quartz, and small fragments of volcanoglass, and sometimes feldspars. At this photo there is no feldspars, but there are acidic plagioclasts like albite are present, very sharp grains. And this is example of X-ray examination of X-ray diffractometry diagram showing example of one of types of silts present at Delta. Smectite, illite, kaolinite deposited from area of presence of limestones, and this is a great mixture when we may discover all types of minerals, very complicated, very complex, because sources of rocks and minerals were from deposited at Nile River was very complex. The material was transported from Sudan, area of Sudan, from left bank, west desert, limestones, etc., and east desert, metamorphic rocks, and other sedimentary, etc., magmatic, and at last in Delta they were mixed with volcano ash. Presence of volcano material in Delta was confirmed by a big piece of pumice discovered by Austrian mission and Tel el-Daba expedition conducted by Professor Bitak under big wall which fall down, which collapsed, was discovered big piece of pumice transported from one of volcano of Mediterranean Sea. This is confirmed by examination conducted by Americans. So because of this, it's sometimes difficult to say what type of primary material was used for preparation of pottery in Delta. What is local pottery, which one is local pottery, which one is import, and from where there are imports, etc. It's very complex. And because of these sources of material in Delta, in Nile Valley, the rocks deposits of the same age are various, because if material was transported from Theban limestone, there are red deposits of clay. If material was transported from East Desert, it's gray, but both sediments are of the same age. It's very difficult for distinguish how it is and how this material was transported, etc., etc. But it's necessary to remember that sediments of Nile of various mineral composition may are often of the same age because material was transported from various directions and mixed, etc. So thank you for listening, and welcome for next small lecture. Goodbye.